All right, last time we met in class, we were learning how to measure to the correct number of digits. Yes, we practiced reading scales on paper, and then we practiced measuring on actual instruments in this room. And the whole goal was to figure out, well, how many digits do we include in that measurement? Does that sound familiar? Okay, so what you were learning was how do you know how many significant figures to record when you measure? So the only thing I want you to write down on the slide is just our definition of Sig Figs, or significant figures, which is the minimum number of digits required to report a value. So when we were using the thermometers and the graduated cylinders and the balances last class, you were learning how many significant figures need to be recorded when you write down your measurement. And then when we use the word significant figures, you're going to see it abbreviated as Sig Figs. And I'll even abbreviate it as just SF once we get used to Sig Figs. Okay. And so Sig Figs are important because when we take measurements, it's important to include all of the digits we can to an accurate degree. So if I have a measurement tool that can measure to the hundredths place, then it's really important that I actually record it to the hundredths place. Okay. Also, on the other side, if I have a tool that can only measure to the ones place, then it's also equally important that I only measure to the ones place. I can't just add some extra digits after to make my number look more accurate. Okay. So you can only include the numbers that your instrument allows you to. Okay, so today we're going to learn how do you know how many significant figures are in a number. We have 6 rules we're going to learn. Okay, so our next couple slides will go through 6 rules on how you count Sig Figs. Then I have a couple slides for exceptions, and then we'll actually practice. So if you're not paying attention, this is the moment. Okay, so pay attention. Go through these 6 rules with me. We will count Sig Figs for the rest of the school year. So our first rule is all non-zero digits are always significant. Okay, so here's our example. Our number is 356. All of those numbers are non-zero, bless you. Therefore, all 3 are significant. Okay, so 3, and then SF is Sig Figs. Bless you. Number 2, zeros in between non-zero digits are always significant. So I call this one the sandwich rule. If you have a 0 and it's sandwiched in between 2 non-zero digits, then this 0 is significant. So 305 would have 3 Sig Figs. Okay, number 3, if you have zeros in front of non-zero digits, these ones are not significant. So here we have this number, 0.0071. These first 2 zeros are not significant, okay? These are just placeholders. So I'm going to say not significant. The reason these aren't significant is if you're measuring, where your actual measurement comes in is the number part. You're going to measure the 7 and the 1. So then these 2 are significant. That's why this number is only 2 Sig Figs. Okay. So zeros in front of non-zeros are not significant. Okay, rule number 4 is zeros at the end of a number and to the right of the decimal point are always significant. So my example is 43.00. All 4 of those are significant. So by adding the 0.00, that's saying that you had some sort of measuring instrument that could actually measure it to that hundredths place. Okay, so you have exactly 43.00 of whatever your unit is. Okay, so therefore they're significant. 9.000, also 4 Sig Figs. So all 3 of these zeros are significant. I also tell people to think of this. Think of it, if you took the time to write 9.000, so you took the time to write those 3 zeros, should they be important? Yes. Yeah. Okay, so if someone took the time to write 0.000, it means that they're significant. Number 5, zeros at the end of a measurement without a decimal point are not significant. So let's say you have 4,300. Okay. No decimal point here means that you're like ballpark 4,300, maybe 4,200, maybe 4,400. Okay. So just because this is not exact, these two zeros are not significant. So then your only two significant digits are the 4 and the 3. Okay, so the two sig figs here are the 4 and the 3. Another example is just the number 200. Okay, 200 without a decimal point. It's just like rough ballpark 200. Maybe 100 something, maybe a little bit more than 200. So the only significant digit in 200 is just the number 2. Okay, so 1 sig fig. And then 5 and 6 kind of go together. So then number 6 is zeros to the left of a decimal are significant as long as the number is greater than 1. So here we have 4,300 again, except this time I have a decimal point. Okay. If a decimal point is included, it now means you have exactly 4,300. Okay, you're no longer just ballpark, it's exact. So that now these two zeros do become significant. Okay. So 4,300 with a decimal point has 4 sig figs. And then here's another example. This one is kind of including rule 4 in it as well. 200.0. If you have the decimal place there, the zeros to the left of it are significant, and then the one to the right is also significant. Okay. So if you write 200.0, it means you know you have exactly 200.0 of whatever you're measuring. Okay. So all 4 of those digits are significant. Okay. Before we practice counting sig figs, we have to go over a couple exceptions. So don't write every word on the slide, but just write what I'm going to underline. So some exceptions are exact numbers. Okay. So if you can count something and you're counting an exact number, then these don't count for sig figs. So let's say we were to count the number of people in this room. My example, I just said there's 10 people in this room, right? Can I count that there's exactly 10 people in the room? Right. There's no like measurement. There's no guessing there. There's no such thing as 9.5 or 10.76 people in the room. Okay. So if you can count something, then those are exact and they don't count for sig figs. Another example is the number 1 in a conversion factor. We'll start learning about conversion factors next week, but here's an example of one. So 1 mole of hydrochloric acid weighs 36.56 grams. The number 1 in the 1 mole is considered like an exact number. So this 1 doesn't count for sig figs. So no sig fig counting. Now this part, the 36.56 grams, does that look like a measurement? Yeah. Okay, this would count for sig figs, okay? It's just the 1 in that conversion factor would not count for sig figs. And then finally, our last exception are definitions. Okay, so definitions also don't count for sig figs. So let's say a dozen is exactly 12, right? So we could write that conversion factor as 1 dozen equals 12. Let's say we're talking about eggs. Oops. The 1 in the 1 dozen doesn't count, neither does the 12. Okay, these are something that we've just set to be a definition, so those numbers wouldn't affect our significant figures. Next week, we'll do a lot of like time conversions. How many seconds are in a minute? Okay, same thing. So you'll see a lot of like time conversions. These are just definitions that we've set. So the 1 in 1 minute or the 60 in 60 seconds, neither of those are going to count for sig figs because we have defined those as like set numbers. So now we're going to practice, I put a couple numbers up here. We're going to practice just counting how many sig figs are in the measurements up here. I know some of you are shy, like to yell numbers out when you're just learning. So like hold up your finger, like how many sig figs are in each number. All right, so the first one's 123 meters. How many sig figs are in that number? Everyone show me. Get them fingers up there. Okay. 3, right? All 3 of those digits are significant. How about 0.123? Take a guess. Is it okay if you're wrong right now? Good. I see some of you. Good. Okay, this one's also 3. That first 0 is just like a placeholder, so that's not significant. How about 40,506 millimeters? Okay, all 5, right? The zeros here, these are sandwiched in. Sandwich zeros are always significant. This one didn't really format as much as I wanted. 9.800 times 10 to the 4th meters. Okay. Take a guess. How many sig figs do you think are in that number? Okay. When you do scientific notation, we're going to ignore like the times 10 to the 4th. Okay. You ignore this part. So then you're only going to look at 9.8000. Okay, so like ignore the whole second half of this number. So how many sig figs are in 9.8000? Show me with your hands. Okay, this time it's all 5, 9.8000. If you take the time to write the zeros after the decimal, it means you can actually measure that many digits, therefore they must be significant. All right, 4.5600 meters. Okay, 5. This is the same rule as the previous one. Those zeros after the decimal point are always significant. 22 meter sticks. Okay, this one is tricky. Can we count an exact number for 22 meter sticks? Okay, so when we do calculations, we just would ignore it. Technically, it'd be infinite. So some of you had like 0. I know it's tricky. It's not that they aren't significant, but if we had exactly 22 meter sticks, could we write 22.0000 and have like an infinite number of zeros? Because it's exact, right? So like an infinite number of sig figs. When we start calculating with sig figs on Monday, we just don't include that number in how we round our answer. All right, 0.07080. Lots of zeros. Okay, leading zeros aren't significant. So 0.0 is just a placeholder. Okay, those aren't significant. However, after you have that first non-zero digit, everything else is significant. So how many are in that number now? Okay, good. 4. 98,000 meters with no decimal point. Okay, just 2. Without a decimal point present, these 3 zeros aren't significant, so your only 2 significant digits are the non-zero numbers. How about 30 meters? No decimal point. Okay, same rule, just 1 for this one. Good.